we're going to start with questions 1 through 12 on the newly released January 24th, 2019 region. Suppose two sets of test scores have the same mean, but different standard deviation. And the second standard deviation is bigger than the first. So right away, my first thought is introductory day of standard deviation. We talked about this. The bigger the standard deviation, the bigger the variability, the more inconsistent. So if the second set has a bigger standard deviation, then data set 1 has the greater variability. That would be false. Data set 2 is the one with greater variability. That's just understanding the concept of standard deviation. The data sets are not the same variability, and certainly it's not that no conclusion can be made. Number 2, we have a log parent graph with a base of 3, and then g of x is going to be the image of it after a translation 5 units to the left, which this is just basic transformation stuff. If you have an f of x, then 5 units to the left is going to be f of x plus 5, where the x plus 5 is plugged in. So it'll be log base 3 of x plus 5 plugged in, option 1. This one would be a vertical shift up 5, this would be a shift right 5, and this would be a vertical shift down 5. Remember, all things horizontal happen backwards, so even though plus 5 would seem like it's to the right, it's actually to the left. When you factor this next one, when factoring to reveal the roots of the equation, which equations can be used? So I would just go ahead and just factor this the way we know how, which would be by grouping. Take out an x squared, left with x plus 2. Take out a negative 9, you're left with x plus 2. So that's one way, that's part way through the process, which I actually immediately realize is this one, so this one certainly can be used. My next step would consist of realizing, okay, those match, so I'm going to take an x plus 2 out in front, and I'm left with an x squared minus 9, which wants to be that one, but the plus 2 is a minus 2, and so those would never be equal. Everything else is the same. And then I would take it x plus 2, and then difference of perfect squares, x plus 3x minus 3. And that's not an option. So this one never came up, but if we just explore it a little bit, this is almost like midway through grouping. So if I were just to take that a step further, these x squared minus 9s match, so I would pull that out in front, and I would be left with x plus 2, which is the same thing, just a different order of that. So this one could also be used. It's in a trickier order. You'd probably have to rearrange your original and group it differently in order to see that come up. But if you just pick up from there and pull your x squared minus 9 out in front, you can see it's the same thing. So 1 and 2 are the ones. So on this next one, when a ball bounces, the heights of consecutive bounces form a geometric sequence. So there's a constant ratio, a constant multiplier to get from one height to the next height to the next height. So if I picture a ball bouncing, it's dropped from some height, it bounces, and every time it gets a little bit less by apparently a common ratio. So the height of the first bounce, so I'm going to say this is the first bounce. This isn't technically a bounce, you're dropping it from that height. So the first bounce is 121. So that would be a sub 1 is 121. And the height of the third bounce is 64. So not the second, but the third bounce is 64. To the nearest centimeter, what is the height of the fifth bounce? So not a sub 4, but a sub 5. We're really looking for what that is. So the key here is figuring out, well, what is that multiplier? Oops, sorry about that. What is that multiplier? This times what would get you to there? And we have a geometric sequence formula. It's right in your reference sheet. Geometric sequence is a sub n equals a sub 1 times r to the n minus 1. So let's say I know my third term is 64, so we'll let n be 3. So a sub 3 would be 64. A sub 1 is 121 times, your r is what we're looking for, and n was my third term, so 3 minus 1 would be 2. So this allows us to solve for r, so we'll divide both sides by 121. Uh-oh. I can't get away from this. Alright, that took a while. Alright, so 64 divided by 121 leaves us with this 0.5289 number, and then square root that number to solve for r. You get 0.72 repeating. So r equals 0.72. So this times that 0.72 repeating number gets you here, then times that again, so we can just confirm that. 121 times that answer would give us this, times that r value again, we can go back up and grab it, should give us 64, which it does, times that r value again would give us the fourth term, times that, take the 64 number times that r value, that'll give us this as 46.5, and take that number and multiply it by your r value to get us our fifth bounce, which is 33.85. So 33.85 is closest to 34. I sort of did that conceptually. You could go and use this again. If you're now looking for your, oops, that was not my fourth bounce. That was a sub 4 and this was a sub 5. If I wanted to find my fifth bounce height and I wanted to just stick with a formula rather than thinking it through, a sub 1 would be 121. My r value is 0.72 repeating to the, and I'm looking for the fifth, so 5 minus 1 power. And if I type that in just directly, 121 times 0.72727272, do that a whole bunch of times, to the fourth power will give me that 33.85. Okay, number 5 is just, hey, I'm a quadratic, solve it. And it looks like there is an imaginary possibility, so they might also be testing that, but we can't solve a quadratic until we get it equal to 0. So you subtract your 9 over. That'll give us 5x squared minus 2x plus 4 equals 0. You can try solving by factoring, or you can kind of just based on the look of the 4 answers, it's not factorable, it's got radicals in it. So negative b is 2, plus or minus the square root of b squared is 4, minus 4ac all over 2 times a. So there's your quadratic formula. That's going to give you 2 plus or minus the square root of 4 minus 4 times 5 times 4. Gives me a discriminant of negative 76. Okay, so there's your imaginary numbers, the negative under the radical. So those are out. And then 76. I think a 4 goes into there. So 76 divided by 4 would give me, this is the same thing as negative 4 times 19. So that's going to give me my 2i. So 2 plus or minus 2i root 19 all over 10. And this, and that are all divisible by 2, so 1 plus or minus 1i root 19 over 5. And then this is common, it seems, on the regions. They split this up, so they do the 1/5 plus or minus I root 19 over 5. So that would be option 2. 6, I haven't even read it, but I can see exponential growth happening. And they give us a formula, so that's nice. We start with 2,000, growing by 4% every 1 year. Which equation represents the amount of money in terms of a monthly growth rate? So 2,000, this is manipulating percentages, growing by 4% every 1 year. If we want the 1 month growth rate, we're going to have to plug in 1 month. The issue is you can't have 1 month and 1 year in different units, so it's probably easiest to change your 1 year to 12 months and then just type this in. 1.04 to the 1 over 12 power. 1.04 raised to the 1 over 12 power, and that'll give us our monthly growth rate. So our starting value is still 2,000, but we're growing at 1.00327, and that's every 1 month. So T is still being used, which is in years. So if I did that, that's happening every 1 month, where T is still in years. I want to keep this in years. So happening every 1 month is the same as the frequency of happening 12 times per year. And that's kind of that frequency formula that we dealt with. So with the percent chapter, we had the T over P concept, and that's what we used here. But if it's a certain frequency and the number of times per year, that means 12 times per year, which would be option 3. Number 7 is, I see tides, I think trig. So tides are a periodic rise and fall of ocean water. So you know your tides go from high tide to low tide to high tide to low tide. On a typical day at a seaport, to predict the time of the next high tide, the most important value to have would be so high tide, to know when the next high tide would be to know really what the period is, what the length of a cycle is. And the time between consecutive low tides is the same as your period, so that would be a good thing to know. And that's essentially it. That's just giving you your period. And if you know your period, you can know when the next high tide would be. I see number 8, we have an estimate of the number of milligrams of medication given here from 0 hours to 6 hours. Over what time interval does this strictly increase? Just look at it. Okay, we got to plug it in. It's just knowing the features of a graph, what's increasing, what's decreasing, and also knowing how to mess with your window. So in our window, we're going from a time of 0 hours to 6 hours, and we're talking about how much of a 400 milligram sample is left. So 0 to 400 milligrams would be an appropriate y-axis, and we're looking for strictly increasing, which is from here to here it's increasing. And that's at 2 when that stops increasing. So it increases from 0 to 2, and that's just knowing how to look at a graph and understand features of the graph.